Welcome to our Senior Secondary Mathematics series. This is part 2 of sets. Let's get started.
So we started with the introduction, then we moved to set notation, then set symbols. Then we dived into three common use symbols, which included the intersection, union of sets, and complement of a set. In this video, we're going to take a look at the Venn diagrams and wrap up this topic with the real world. So let's get started. Venn diagrams. So Venn diagrams are a visual way to work with sets. So by visual, what I mean is how to draw sets and how to get information from sets that are drawn. When working with Venn diagrams, we usually present a universal set by a rectangle like so, with the E indicated on the corner, and all other sets are represented by oval shapes like this. So there are three basic ways to draw Venn diagrams. Let's take a look at them. So the first kind is called the disjoint sets, and it is usually represented or drawn like so. So you can see that set A and B are not touching, so this shows that the two sets are disjoint, that is, they don't share any common element. So the other is joint sets, usually represented by first having the universal set and two sets like so. So these two have got this joint section here, which is usually an intersection area, and it shows elements that belong to both of the sets. The last kind is subsets, which are usually drawn like so, having this set and another small set inside. So the set that is within another set is a subset of the larger set. Shading relationships. So usually when we're working with sets, we try to show various relationships, how various shapes are related by shading. So we usually work with this kind of representations, that is the joint representations, because with this we can show a lot of relationships. Let's get started with some example relationships that we can show just from this. The first kind is B. So how do we show B? Yeah, so B, we just shade B. So this is simple. I've got two sets. How do we show that this is B? We just shade B. The next is B complement. How do you show those elements that are not in B? So we just shade everything else apart from B. Okay, let's move on. The other kind is A union B. So how do we shade elements that belong to A and B? How do we shade the combination of A and B? Simple. We just have our A and B, and we shade A and then B. We leave the rest. We can move on to A union B complement, which is just the opposite of A union B. That is, we shade everything else apart from A and B. How do you shade A intersection B? How do you shade that common area that is shared between the two? So yeah, we have these. So we can see that the middle part is the intersection, so we just shade that part. Yeah, so A intersect B complement. So how do we show intersect B is, of course, elements that belong to both sets, but how do you show those elements that don't belong to both sets, as the complement symbol here demands? So we just shade everything else apart from the intersection area. So this is A intersect B complement, that is members that don't belong to A intersect B. So this is the basics of Venn diagrams. The next time we're going to be using Venn diagrams is when we are solving problems, that is in the next section, which is the real world. Let's move on. So let's get started with the real world. So whenever we're given a problem extracted from the real world, there are various steps that, if taken, are usually helpful in solving a problem. So let's take a look at them. So step 1, identify the needs of a problem and then assign symbols to represent the statement. So if the statement goes like, in this group there is a group of kids who like playing video games, we can say let B be equal to number of kids who play video games. Step 2, interpret the given data in set operations and symbols. This step requires one to use the given data. Let's say the information that has been given is there are these kids who like video games, and also they like let's say going to school. We can choose to use A union B or intersect B depending on the statement, and we'll learn how to do so later. So this is what it means to interpret the given data in set operations and symbols. So on top of the two steps that have been outlined, there's another additional skill that is essential when we're solving word problems. The table is going to help us acquire that skill. So in the first column we've got words, which are words found in statements that describe a reward problem. Then the second section has got symbols, which are the equivalent symbols of the words. And in the last column we've got examples, which just represents which just shows us how we can convert a word into a mathematical a set operation, so to put it. So if we start with the second row, we've got and, which usually means intersection. For example, F and B, or football and basketball might mean F intersect B. The same applies to the word both, which has got intersection as used in the example. Both F and B is F intersect B. The other interesting one is but. So this is also used to represent intersection if used like so, likes F but also B, it means F intersect B. Then the other one is neither nor. So if we've got a statement that contains neither nor, what this means is we're talking about the complement of the union of two sets as shown in the symbols. So set 1 union set 2, then complemented. So as shown in the example, you can see neither F nor B means F union B but complemented, so elements that are not in F or B. Then the other one is either or. This just represents union. So if we say either F or B, just F union B. The last one is or, which is also union, and you can see in the examples F or B is F union B. Let's move on. So there's one important note that we should always keep in mind when we are working with such problems. So the expression likes football only is usually used to indicate that a given member belongs to a given set only and is not shared with other sets. But the statement likes football shows that a given member belongs to the set, but we cannot ascertain if they just belong to that set or they also belong to other sets. So always keep that in mind. So to learn how to apply the various concepts we have learned, let's take a look at an example. So there are 28 people in a meeting. 12 are farmers, 14 are soldiers, and 6 are both farmers and soldiers. So the first question is, how many are farmers or soldiers? The second is, how many are neither farmers nor soldiers? So let's see what we can do. So let's take a look at the solutions. So the question is, how many are farmers or soldiers? So step 1, let F be farmers and S be soldiers. Step 2, let's see what we have been given, and then let's convert that which we have been given into mathematical symbols. So we've been given that the total number of people that were present at the meeting were 28. So to represent the number of elements in a given set, we use this symbol n. So like so. So numbers of E, which is number of the members in the universal set, is 28. Also numbers of farmers, which is F, is 12, and numbers of soldiers is 14. Now if we take a look at the last statement, which was 6 are both farmers and soldiers, we can convert this like so. Numbers of F intersect S is equal to 6. Why? Because we have got both in the statement, which represents intersection. And since we are talking about numbers, we can add the number symbol outside the F intersect S, and that is equal to 6. Now to clearly see this, it is advisable and it is efficient to draw a Venn diagram first. So So here's the Venn diagram that represents all the people that were present at the meeting. So inside it, of course, we have got a set of farmers and a set of soldiers. So first and foremost, start with the total number of people who were farmers and soldiers, and that is F intersect S, and we know that F intersect S is 6. Now we move on to look at the total number of people who are farmers only. We do this by subtracting the total number of people who are both farmers and soldiers, that is the intersection set, which is 6, from the total number of people who are farmers, which is 12. So 12 minus 6 is 6, and we indicate that in here. Next, we do the same for the total number of people who are just soldiers only. Uh, so we subtract 6 from 14 and we get 8, and we indicate that here. Now there were 28 people at that meeting, so we can subtract the total number of we can subtract the number of people who are farmers and that who were soldiers, and that were both farmers and soldiers, from 28, which is the total number of people that were present in the meeting, so that we see if there were others who were neither farmers nor soldiers. We do this by doing like so: 28 minus 6 minus 6 minus 8, and we get 8, and we indicate it there. So this is the number of people who were neither farmers nor soldiers. They were present in the meeting, but they were not farmers or soldiers. Um, Now we can continue to answer in our question. So our question is, how many are farmers or soldiers? So if we take a look at the keyword, we have O, and O means union. So we're talking about F union S. That is the total number of people who are both farmers or soldiers, written like so.
So the solution is we're looking for numbers of F union S, number of F union S. So what does it mean, number of F union S? So F union S, it means we're interested in F and S. So we're interested in the number of elements in F only, the number of elements in both F and S, and the number of elements in S only. That's how union is. It collects all the elements in here, here, and here. So numbers of F union S simply is this plus this plus this, which is 6 plus 6 plus 8, which gives us 20. So that's how to deal with union. You collect number of elements in F only, number of elements in both F and S, and number of elements in S only. The next question is, how many are neither farmers nor soldiers? So the keywords here, neither, no. If you remember our table, neither, no, means the complement of the union of two sets. So if you have two sets, then if there is a union of this set, now we look for elements that are not in that union. That's neither, no. So we're looking for members who are not farmers or soldiers. So we represent this as F union S complement. And since we're looking for, the question says how many, so meaning that we're dealing with numbers, so we have to add the number of symbol here. And we can write this as number of the set of interest inside the brackets, F union S complement. So what is our answer? So F union S complement. So we're looking for everything that is not in here or here or here. So which is, as you can see, it's this outside, which is 8. So numbers of F union S complement is 8. Let's go to example 2. So example 2 reads, actually before we read the question, this is the Venn diagram for example 2. So I've got universal set E, which has got these elements and this one here. And when you're given a Venn diagram, make sure that you don't make a mistake of not seeing this one. This one tries to be invisible because you get focused on these two, so you forget about this one, but it's part of the universal set. and we have got set A, which has got this, and set B, which has got this. So the difference between this question and the previous question is, in the previous question we had one number here, and one number here, which was representing the number of elements in A only, and in A and B, and also in B only. But in this case, these are not number of elements, they are members of the sets. So these 6, 8, 2, 4 are just members of set A, and these are just members of set B, and this 3 is just a member of the universal set. So what I mean is, if someone asks you like, what is the number of elements in A, you don't have to add these numbers like 6 plus 8 plus 2 plus 4. No, the number of elements in set A is 1, 2, 3, 4. You count them, 1, 2, 3, 4. So that's one key difference between this and that, and you can tell just from the way they have been put, and also maybe the way the question will be structured. Let's take a look at the question. Using the Venn diagram above, write set A intersect B. So they want the set A intersect B. So in the previous example, we're looking at numbers. We're only interested in the numbers of sets. So in this case, we don't have an n here, so we are not interested in the numbers of A intersect B. We're just looking for the set A intersect B. So A intersect B in Venn diagrams is this part which is shared by the sets involved. So A intersect B is 4 and 2. So we can write our answers 4 and 2. The next question says, set A complement intersect B. A complement intersect B. So there is a reason why we are then shading Venn diagrams. So if you look at here, and if you can shade just by looking in your mind, or even if you want, you can get a pen or a pencil, then you start shading. So A is this, A complement is everything outside there, so you can shade everything outside A. Then intersect, which means they're looking for the common region. So all the things you have shaded intersect with B. So you look at B, then you shade also B. So intersect means the common. So you have to ask yourself, which is the common area that I've shaded. So A complement is everything outside A, and B is here. So you can see that the common area will just be this part here minus this part, because this part you didn't shade it when you were shading A, you only shaded it when you were shading B. And we're looking for that part which has B, which was shaded when you are shading A and when you are shading B. So of course you can develop that skill of shading if you want, but there's another way of dealing with this question. The other way is to list elements in A complement and also to list elements in B. Then you look for elements that are common to both sets, like so. So A complement intersect B with these elements that are in A complement, which are 5, 7, 1, and 3. A complement, remember, is everything outside A, so 5, 7, 1, and 3. And we also list elements in B. So in B, it's 2, 4, 5, 7, 1. So 2, 4, 5, 7, 1. Then we ask ourselves, what elements are common to both sets? And you can see it's 5, 7, and 1, because 5, 7, and 1 is also a 5, 7, and 1. So this is our answer. The next question says, using the Venn diagram above, write set A union B. A union B. So of course, A union B, it's A and B combined. So if you want to use the technique of shading, you can just shade A and also shade B. Then you ask yourself, I have to combine everything that I've just shaded. That's what union means, which means you are going to combine what is in A and what is in B. Then using the method 2 of this thing, you can just list the elements of A and the elements of B. So elements of A are 6, 8, 4, 2, and the elements of B are 4, 2, 5, 7, 1. Union, you put them together. But you have to remember that elements that have already been listed here should not be listed twice. You could be tempted to write the answer as 6, 8, 4, 2, 4, 2, 5, 7, 1. But 4, 2, it's present in both sets. So just write them once, 6, 8, 4, 2, 5, 7, 1. The other way I used to do, if I don't feel I have time for shading, I could just look here. Union is 6, 8, 2, 4, 5, 7, 1. So that's how to deal with union. The other question is set A union B complement. A union B complement. Again, you can use the technique that you prefer, but what they're talking about is you combine elements that are in A and elements that are in B complement. B complement is everything outside B, elements that are not in B. So if you want, again, you can use these things. So A is 6842 and B complement is 683. These are the elements that are not in B. So it's union, so you put them together. So it's going to be 6842. 68, we have listed 68 already, which is 6 and 8 here. So if something has already been included in the answer, you don't have to include it. You have to list elements once, not twice. So 6842, 6 we have already dealt with it, so we skip 8, we have already included it, and 3 we haven't included it, so we include 3. So answer is 68423. Sorry for this. Yeah, that was a typo. The last question is find numbers of A intersect B complement. A intersect B complement. So this question has been structured like the questions we dealt with in example, in the previous example. So they want A intersect B complement. So they want A intersect B complement. So they want members that are in A and those which are not in B. But they want their numbers, not the names of the members or the set A intersect B complement. But for you to do that, you have to identify A intersect B complement as a set. Then from there, you count how many members are in A intersect B complement. Then you write as numbers like so. So the first stage, A intersect B complement, we listed elements in A and also in B complement. So A it's 6842, intersect B complement, it's 683. So what members are in A intersect B complement? So what members are common in A and B? It's 6 and 8. So A intersect B complement is 6 and 8. Then the last part is N number of, what's the number of A intersect B complement, or what's the number of these two elements? 1, 2, they are 2. So the answer is number of A intersect B complement is 2. We don't even include the curly brackets because this is number of is just a count of numbers, but sets are the ones that are supposed to have curly brackets when you want to describe the set or to list the members of the set. So this marks the end of this topic, sets. Make sure you like, subscribe, and share. Watch out for the next topic, which is algebra. Happy solving.